Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look at an application to display CSV files without amending or reformatting the data in the display grid. Today we're going to be doing our video slightly differently. I'm going to start off by showing the finished application, and after demonstrating this, we'll double back and have a look at the code that created it. First of all, this application was created to solve a specific problem. We have in this folder a CSV file. One of the tasks you may have to do on a daily basis is to look at CSV files, to ensure that the construct of the file is intact and there is no dodgy data within it. There are a number of applications you can use to view a CSV file, ranging from Notepad right up to expensive spreadsheet systems. If we first of all look at the CSV file in Notepad, we will see the construct of this file does look like a standard CSV file. We have a header line at the top, which is comma delimited. We have a number of data records underneath this header line. Each of these rows of data is delimited by a comma. As well as the text contained within the data rows, we also appear to have some dates and some numbers. The dates are in year, month, day format, and the numbers are zero filled. This particular CSV file looks fine as far as I can see by looking at it in Notepad. However, Notepad does not arrange the text very well to make it easy to check a file. If we attempt to open the file up in Excel, we will see, first of all, Excel gives a warning to say that by default, Excel will perform the following data conversions in this file, and first of those is to remove leading zeros. Ideally, we wish to see the file in the format in which it has been presented. We do not want an application making any conversions, changes, or manipulation of the data that came in. So in this case, we will click Don't Convert. So we can see in the account column, all the values are zero filled. However, in the start date column, Excel has converted the dates into a different format. It is now sitting in the regional day, month, year format. And as this is not the format that the file was presented with, this can be a problem if you're looking for issues with the data. Now, while there are things you can do in Excel and other spreadsheet systems to prevent such manipulation and conversion, ideally you want to view the file as it was presented straight away. So that was my task in creating a PowerBasic application that would perform this task. So I have created an application called viewcsvfile.exe. If we double click on that application, it presents us with a file selection dialog, and there is our HR staff list CSV file. If we open that up, we can see on screen we have 33 records of data with the header line. The application has automatically widened the columns based on the data contained within them. It has also presented the start date in the format that it was presented in, as in year, month, day, and the account column is zero filled as it was presented. So there has been no manipulation of data that has come in on the file. We can see the file exactly as it stood, but it is better presented in rows and columns. And each alternate row is color-coded to make it easier to actually see the data. If we click the widget at the top right-hand corner of the screen, we can change the size of the dialog up to the full size of the screen, or down to a minimum size beyond which it will not progress. So if that is our application, how did we achieve this in code? Let's have a look at the application then. This is the source code for our application. This is set to compile into the name of viewcsvfile.exe. If we look slightly further down, we can see the include files that have been used to compile this application. We're including myLittleGrid SLL. That's the static link library for the myLittleGrid grid control. I'll put links in the description below where you can actually download this free add-on. We're using 3 sets of libraries which are of our own construction. One to allow you to easily use My Little Grid, one for file handling routines, and one to provide some macros for you. Additionally, this application makes use of the Layout32 static link library. This is a purchase library which I have found incredibly useful to allow you to resize your dialogues and automatically position the controls on the dialogue according to the size and position of the dialogue. This static link library will not be included with the source code when I upload this. So I've set it up so that if you comment out this single line of code, it will not use that library and will make use of code elsewhere in our application. While this isn't as good as the Layout32, it's enough to let you demonstrate how this application works. But I would recommend the use of the Layout32 library. It's a very useful library and saves you a great deal of time when designing Windows dialogues, especially those that users will want to resize. So let's have a look at the pbMain function, the first function that is executed when our application runs. The first thing the pbMain function does is it has a look at any parameters that have come in on the command line. This allows you to use this application as the default application for a particular type of extension. So all my CSV files will launch this application if double-clicked on. If we just double-click on the CSV file, it will launch this application automatically. If something comes in on the command line and the application cannot find that file, it will give you a message box to say the file cannot be accessed. If nothing comes in on the command line, you will then be presented with a dialog allowing you to select a file. This will default to the current path of the executable, and will look for all files with a CSV extension. And with the flags, we've set it to where the file must exist, and the path must exist. So this prevents the user typing in file names that do not currently exist. And then we will display our dialog. The dialog is fairly straightforward. There's a toolbar at the top of the dialog, there's a label to display how many records we pull back from the file, and there's a button to exit the application. We're using one of the built-in functions in one of our libraries to read a CSV file into a 2-dimensional array. And after that is the initialization section for My Little Grid. This takes the output from our function, which is the rows and columns within the file. We have additionally set an option to set a right-click menu. So if the user actually goes into the application, right-clicks, they have 3 options. They can copy the data within a specific cell, or they can sort the column based either on ascending or descending characters. So if we pick the name column, right-click and sort it alphabetically. This gives you a very easy and quick way of sorting data within our grid without changing the underlying file. And we can return it to its original. We'll cover more about the sorting when we get to that line in code. My Little Grid has a great number of options, but we're using most of the basic ones to set this up. And this line of code here is the single line of code that takes all the data in the array we have loaded from the CSV file and places this data within the grid itself. We are then updating the label on screen to say how many records have been returned by loading the file. We're then making use of 3 functions within our My Little Grid library. One to widen the columns in the grid. This sets the column width to be the maximum width of text either in the headers or in the data rows. The second function color banks the grid rows in alternate colors. This makes it much easier to read when you have a large spreadsheet. And the final command is to refresh the grid to ensure everything we have just done gets drawn to the grid on screen that your user can then see. Further down at the end of this particular function is our code for Layout32. Layout32 gives you a mechanism by which you can actually apply rules to each of the objects on the screen. You can say, and in this case, for the grid, we are allowing the grid to be stretched. when the dialog upon which it sits is made larger. It will also contract when the dialog is made smaller. And it's tied to the right and to the bottom of the dialog. We also have two rules for the exit button, the abort button. And this is to move the object on screen based on the bottom right-hand corner of the dialog. And the rule at the very bottom of this section is to allow us to set a minimum size for the dialog. The user can make the dialog larger than this, but it will not allow it to make it smaller. So with these small number of rules, you can control what appears on the screen. Well, you can code this yourself in the application, which we will see in a moment. If you have a large number of objects on the dialog, it's much easier using this rule-based approach, where someone else has actually written the code for you. So if we now have a look at the event handler. In the event handler, this handles all the objects on screen. If the layout 32 code is not being used, this will actually be included in the application. These are the additional variables we'll need to handle all the resizing code ourselves. Initially, when the application loads, we maximize the dialog on screen. Maximizing the dialog will kick off a size event. The dialog has changed size, therefore the code in here will be executed. If the dialog has been minimized, this exits straight away, as it's not visible to the user, therefore there is no code needed. And this large section of code here is the code you will have to have in order to resize the objects on the dialog if you're not using layout 32. Basically, it's working out the size of the dialog, the size of the client area of the dialog, and working out whether the minimum size has been reached or not. Then we have to get the size of the exit button to work out its new position on screen. And then finally, we have to do the same with the grid control itself to work out how wide it is and how wide it needs to be and how high it needs to be to fit on the newly resized dialog. If we're using layout 32, these lines of code are not required. And our final section in here is to refresh the grid. My little grid itself is set up to use notifications. When the user performs something on the grid, a message is sent to the WM notify event inside this callback function. And we're using this MLGN. This variable is a user-defined myLittleGrid pointer. This allows you to work out that it has indeed been your grid that has been clicked on. You can, in theory, have more than one grid on a dialog. In this case, you can determine that the grid being selected is the first grid. And this section of code will only apply to the first grid. We're then looking at the NM header code. This allows us to pick up the event that has been triggered on the grid control itself. In this case, we're looking at the right-click menu. A user has right-clicked somewhere on the dialog, and we need to pick up what menu item they've actually picked. For this particular grid, there are 3 menu items. One to copy to the clipboard, a second one to sort A to Z, and a third one to sort Z to A. Sorting is quite straightforward. We merely have to send a single line of code using the send message command back to the grid. One to say it's sorting, a second parameter to say we want an ascending sort, and the final parameter is to say which column we wish to sort on. In this particular application, I've left all the columns as being character columns. Therefore, all the sorting being done on this particular grid will be done as if everything are straightforward string characters. You can define in myLittleGrid columns to be numbers or dates, and myLittleGrid's sorting routine will respect these choices. In those cases, numbers will sort numerically, as will dates. I usually set up a Boolean flag to say that something is sorting. You can test this later on in the code to ensure that you're not performing any other changes to the grid while it's in the process of sorting. Sorting is very quick, but you don't want something else triggering while you're in the middle of a sort. And with MyAutoGrid, one of the things to remember is to have a WM paint event. When the grid is being repainted, you need to do a control redraw on the grid itself. This ensures that the grid is shown correctly and doesn't have any bounding lines in the middle of the grid. Further down our code, we have the event that handles clicking on the Open button on the toolbar. This allows a user to select a new CSV file to load. This uses almost exactly the same code as we saw at the beginning of the application. It launches the Display Open File dialog, allowing the user to select a CSV file from somewhere on the machine, or indeed from the network. And again, we're using the read the CSV file into an array again to load whatever's in the CSV file into a two-dimensional array, which can then be placed on the grid. MyAutoGrid stores the information that appears on the grid in an array, and you can use the inbuilt function mlg_array_redim to resize that grid. And then you can use the putx command to take whatever's in your array and plonk it straight into the grid itself. And we can then widen the columns, colour bank the rows, and refresh the grid on screen. So you can see from this, there is not a great deal of code involved in displaying a CSV file to the user using a MyAutoGrid control. And with the addition of the layout 32, you can make the dialog resizable and aware of larger screens or smaller screens depending on what the user is actually using. I'll put links to MyAutoGrid and to the layout 32 in the description below. Hopefully you'll find this utility useful in your day-to-day work, but that's it for today. Thank you for watching.